to car guy with Scanner Danner. You asked for it. I'm giving it to you. So is he.
Hello.
Don't laugh. Don't laugh.
This is crazy.
So what do we got here? We got.
We're doing actually a live job for class. It's a 2001 GMC Sonoma. Sonoma, right, guys? Yeah.
And it's broken.
4.3.
Go figure.
And it's got a dead misfire, number 3 cylinder, and we're gonna walk.
How do you know it's number 3 cylinder?
Actually, I cheated a little bit before we did this.
Well, don't cheat because it's got a misfire. We're gonna find out
dead
what's
miss.
going on.
That's
dead
right.
miss.
We're not sure what cylinder yet, and we're gonna show you how to identify that.
So why don't we get started and go over there?
All right.
We're gonna have some help from some students.
Absolutely.
Like that.
Yes.
Right. So let's learn something.
All right. Cool.
So now we know we've got a misfire in this truck. What's the next step?
Next step, I would go trouble codes, OBD2, 96 and up, and that would certainly depend on the year of the car, pre-96.
And this is a 2001?
This is 2001. So
and are we sure it has a 4.3
It is not a 4.3, it is a 2.2.
Oh, okay.
So first mistake there, but no big deal.
No big deal.
It is a 4-cylinder, 2.2.
Okay.
And, so for a misfire, OBD2, we can get a little bit of help for a trouble code sometimes. Pre-OBD2 cars, of course, really not too much help with that.
Sort of.
Cylinder specific.
Well,
anyway,
we don't have fancy machines we can hook up, but we can still use the tool between our ears, right?
Yes, absolutely.
All right.
So we'll see if we got it.
So we're going to hook it up and look for codes.
Display codes is where we're going. And we'll go history. And, of course, there's no codes. This is actually one of our other instructor's vehicles, and he was in here already, and I believe he cleared the trouble code. So trouble code display is not going to help us identify misfire in this case, but it's a good first step anyway.
So we don't have any codes.
So no codes.
How are we going to do it?
Going back, in this case, we'll go to our display data, and nice of GMs to give us misfire data. Not all vehicles have misfire data, but it's nice that this one has it, so we're going to try to use it to our advantage. And what we want to look at is our misfire history and our misfire current. And what I generally like to do when I have a large data display list is customize it and limit the data PIDs. Really not necessary in this case, but because it speeds up the process when you do that. It might make it a little bit easier to see. So we're going to do that. We'll go just our misfire current and history, and should make for a little bit better view on the screen too. So we got history down here, the bottom 4, and the top 4 would be current. And then we're going to start the car and see if we get a counter that's going to pick it up. This is a stick, so I got to jump inside of it real quick.
Definitely has a miss.
Yeah, you probably picked that up on the camera too.
Feels kind of good.
If you look up here, you see we got pretty much a dead miss on the cylinder number 3. We have a dead miss, and that's what you're looking at, is a 200 cylinder firing event that is misfiring 200 times in that 200 cylinder firing event, and that's why it's running back to 0.
So what do we do next?
Next thing we got to think about the 3 things, right? We've talked about this, guys, is spark, air fuel, compression. We're missing one of the 3, and I'm always looking for next easiest step, so I'm not sure where this is going to go, but I brought a couple pieces of equipment out. I brought a gas analyzer so we can actually check tailpipe readings and see what type of misfire. We talked about that, right? Like a stuck open fuel injector, for example, or I'm sorry, stuck closed fuel injector. Our hydrocarbon levels will be very low coming out of the tailpipe, so we can use that as a guide. We can scope the injectors, we can do relative compression tests, we can look at secondary ignition. I generally like to pick the next easiest one, but maybe for this we show them all, whatever.
Well, for you, what's the next easiest one?
Next easiest one for me, if I'm working in the field, I'm going to do a clear flood crank, and I'm going to listen to the way the engine cranks. All right, so I'm going to do a cranking, basically relative compression test. I'm just going to listen to the way the engine cranks. And
you're also going to put your foot to the floor all the way on the gas.
This would be a clear flood crank, so it would be TPS, that's throttle position sensor, or gas pedal all the way to the floor. And not all cars have clear flood mode. Be careful. Funny story on that.
Okay. I thought they did.
Not all cars have it.
Learned
that the hard way.
Which one didn't?
Well, look, I was changing oil early in the field for my boss's Jeep, and I didn't put oil in the filter. And he says, he was real anal about making sure that there was oil in the new filter before I started. Okay. I'm like, don't worry, I'll just do a clear flood crank, and we'll fill the oil filter up by cranking it over before I let the car start. Needless to say, this Jeep, it revved up to about $5 grand with no oil.
What year?
I forget. This would have been.
Was it older?
94.
That's weird.
It should have it, but it didn't. I put it to the floor. That's what I'm doing now. Gas pedal to the floor, and that input to the computer during a crank will eliminate injection pulse.
A TPS reading past 80%.
TPS reading past 75, 80%. That's correct. So that's what I'm doing, cranking it over, listening to the way the engine cranks. All right, so sequence is important too. In this case, I'll just try it again. We'll see what happens. Pedal to the floor, turn the key on, try it again. You know, I just did this out in the parking lot. I really did. I promise.
I promise.
Go figure.
Clear flood mode is...
Clear flood mode is not
random.
100%.
It's random.
It is random, for sure. Let's try this again, one more time. There it is.
Sounds normal.
Yeah, it sounds pretty normal. Maybe a little bit of an inconsistency there, but certainly not what I've shown in my other relative compression video. You can definitely hear a low compression cylinder. So I'm not thinking I want to pull the number 3 spark plug out and put a compression gauge in it.
Well, I was going to say, and what you're trying to rule out here is a mechanical issue with the engine causing the misfire, like say a burned up valve or something going on with a piston, some kind of compression loss causing the miss.
That's right.
Okay.
Yeah. So again, just direction. Now we might go back to that. One of the things about doing drivability work, which you know, is sometimes you come back to a test.
You keep guessing.
Yeah. For sure.
You keep guessing until you get some evidence.
That's right.
Well, would you agree that a lot of it might be based on your experience in the field?
Absolutely.
Like, say, for instance, you work on these trucks all day long.
Absolutely.
And you get a miss on cylinder number 3.
Yes.
But you've seen 12 other ones with a miss on cylinder number 3, and it was problem X.
For sure.
You might look to problem X first, just based on your experience with that vehicle.
And that's where you know, experience is everything, where you really start.
I mean, you have to start with the basics, and you have to know what to look for to start with before you gather that experience of those 12 vehicles. But, you know, once you get to that point, then, yeah, it could speed up diagnosis.
Then you get those people that say, "Well, you found that in 5 minutes. Why should I pay you $100?" But
because the first time I did this, it took me half the day.
That's right.
And I got paid for 1 hour on it. I'm making up for lost time.
Yep. I think the next thing I want to do, guys, is let's put a probe in the tailpipe because we got the machine here.
Let's be gentle.
Yes. A exhaust analyzer probe in the car's tailpipe.
So we can actually monitor its ignition. No, not you, viewer.
Yes.
We're going to put the probe in the truck.
Yeah. So what we're looking for is what kind of hydrocarbon readings, and this is not a foolproof test either. I mean, this is just a direction test. And with the engine being cold, too, we're going to have elevated emission levels. If hydrocarbon levels were very high, then we can go towards spark or compression problems. If hydrocarbon levels are very low to normal, it's going to be maybe injector related. So not foolproof, because the cat's going to do its job and clean up some emissions too, but it is a decent direction test. And actually in the field when I do this, I'll pull, I'll take the exhaust hose off and just smell it. Just use my nose and you can tell.
Well, how about this? Just pull number 3 spark plug.
Pull number 3 spark plug.
Take a look at it.
We could do that.
Just look at it visually and see. You can almost see if it was running lean, or
we can do that too.
Had some other issue to it, or if it wasn't firing.
Yes,
or,
if we didn't.
Or maybe there's a carbon track down the side of it that we can visually see.
Absolutely.
Something like that.
Yep. And that's that's the one thing.
I'll put a probe in the tailpipe if you want.
That's the one thing about doing this, though. I mean, you bring up a good point. Is which way do you what method do you want to use?
And that's exactly right. There are 100 different ways to approach a problem. So nobody's way is right. So if you got one guy in the shop that wants to approach it one way, fine. You know, he's got his own way of doing it. He still comes to the same conclusion. That's what this is. A lot of this is open to interpretation. Different technicians go about different processes in their diagnostics. So it's not a question of being right or wrong. And you know, ASC tends to steer us in that direction, technician A and B, that kind of thing. But it doesn't necessarily have to be that way, because there's a lot of things that you can do and try, and experience, once again.
Yeah, myself, personally, I don't really do much visual on, a system like this, on pulling a spark plug out. I'll do that probably later in my approach, do you know what I mean?
Sure.
Because I'm big into scopes, I would hook up a secondary ignition and look at the waveform first. To me, that's easier, but I can definitely relate to people that don't have a scope and need another method, and that's going to be it.
Well, this is where automotive education comes in. You know how to use this tool that he's got. So let's go about it your way.
Okay. So you want to do the tailpipe test
Heck
first,
yeah.
or you want to do
I mean,
secondary
I
ignition?
don't have this fun stuff to
All
play
right,
with,
cool.
so we're going to do this.
Well, let's do it.
Let's do this.
All right, cool.
Let's analyze our tailpipe.
This is an old school machine. I'm just actually going to go to.
So you've already got the probe stuck in. I can
Is
see.
it?
Yeah.
One of my guys took care of that. For
Yeah, they
me
did,
today.
and they got the exhaust hose hooked up.
Awesome.
You guys are awesome.
So we'll be safe. We won't be falling over dead here. And really, we're going to, unfortunately, the oxygen sensor for this tailpipe machine is dead. This is old school, but I'm not worried about this. I'm looking at this guy right here with this
Well, can we
carb
just talk about what we're looking at here real quick?
Sure. Main two gases I look at for this, I know a lot of guys use the CO2.
Okay, that's the RPM reading.
but I don't have anything hooked up front, so
Okay.
I'm not worried
So
about that.
that's going to read 0 pretty much.
Vacuum is going to be 0 too because I'm not hooked up to the car. The two main gases I'm looking at, my CO, which is my rich indicator, and then my HCs, which is my misfire gas, is my main two that I'm looking at.
HC would be hydrocarbons.
HC's hydrocarbon, CO is
Leftover
carbon.
gas. Leftover
That's right.
gas that wasn't burned.
Carbon monoxide would be the CO. So that's the ones, and again for this one, this is a guy I want to focus on, but I need to let the car run for a minute or so, let it stabilize, and then we'll get a reading of what that hydrocarbons looks like.
All right, now it's running. We're going to let it get into closed loop?
Yeah,
or?
for sure. I mean, when you first start a car, you're going to have elevated readings here. So
And why would that be?
Well, the car needs to run rich. I mean, if you think about even just using a weed whacker at home and you start it up when it's cold, you got to pull the choke on.
So yeah, you choked it up. So you're giving it less air and more fuel
That's
to run
right.
until the
right.
engine gets to operating temperature
That's
when
right.
it's more efficient.
That's correct.
Which is the whole premise behind open and closed loop.
That's right.
So in the end,
yep, your readings are going to be high for that reason. So, I mean, you don't want to overanalyze this high CO number on an initial startup. So
you want to let it run for a bit.
Yeah.
Normal out.
Yep. Can you hold that at $2,000 for me? And that's going to hasten that process
Speed
a
up
little
the process.
bit. And again, this test isn't foolproof because we have a catalytic converter that's going to clean up the emissions, and using these hydrocarbon numbers with a cat in play, I got to tell you though, those are pretty low for a dead misfire, even where we're at right now.
So how long would you say it would normally take, or what would be a good indicator
Man,
that you're now in closed loop?
It's going to be different per car. I mean, there's some specs out there. Remember, Dan gave us a spec of 150 degrees coolant temperature and things like that. Let that idle. I would say we're in closed loop right now based on these signals that my CO is very low. You guys see this up here? Look how low my hydrocarbon readings are.
It's a nice CO2 reading too.
Yeah, and here's the thing. When you have an injector problem,
CO2 readings near 15, 14 usually indicate complete combustion.
but look, guys, look how clean this is. I mean, I could take the probe off of this tailpipe and we could run this car in this room and really not die with the numbers that are coming out of here. And what this screams to me right from the get-go is a fuel injector problem. And we'll prove it as we go here, but I showed you guys this. Remember, I shot the video and I didn't upload this one yet. I need to. What I did is I took a known good car and I disabled the injector and I showed this machine and we got our numbers, and then I plugged that back in and disabled spark and we had our numbers, and it was a real good comparison for an ignition misfire and the type of levels you have compared to a fuel injector misfire and the levels we have.
All right, let's talk about that a little bit and how it relates to the HC. If it was, say, an ignition event that wasn't occurring, you would have extra HC
Absolutely.
coming out the tailpipe.
Yeah, absolutely.
So that's what you're looking to see.
Absolutely.
But the fact that you don't
That's
might
right.
indicate that the injector itself is not firing as it should.
That's correct.
So therefore, the misfire is due to the fact of a lack of fuel,
That's right.
which would be seen here with the low HC.
That's right. And it's funny, if back in the day when we did tailpipe emissions in Pennsylvania here, for this car, if this was a tailpipe test, they had numbers, I think it was less than 220 for
Right. I think
HCs
it
and
was around
1.2,
220,
but they jacked it up, I think in 94, 95, it was like under 130 for HCs and less than 0.8 for CO. But
So it would technically pass.
Right now, this car
Technically,
would pass.
but don't
That's
they
right.
have the thing if you have a check engine light with
That's
a
right.
misfire event that it will not pass?
That changes now with OBD2, but if this was a tailpipe emission test, this car would pass emissions right now
Interestingly
with a
enough.
dead misfire. And as you say, I mean, that screams a fuel problem. So if it was a ignition, compression, the fuel's getting put in that cylinder, but you're not burning it if it's ignition or compression, so you're getting raw fuel right out of the tailpipe, we'd have high hydrocarbon levels.
So can we try to prove this theory through maybe pulling that spark plug and having a look at it?
Sure, yeah, we can do that.
You know, to sort of go through the backyard approach as opposed to having, you know, not everybody's got a 5-gas analyzer.
For sure.
Let's go over to the car and pull the spark plug.
Shut this off, we'll pull the number 3 spark plug out, we'll take a look at what it looks like. And again, if this is something I don't use myself, but you know, you guys for sure, and I don't know how much Eric uses it, but looking at spark plugs to know, you know, what's going on in that cylinder. It's just a test.
Well, if nothing else, you can get a comparison from one cylinder to the next.
For sure.
And if you notice that something is up with a particular cylinder, that's where you want to focus your search.
That's right. Yeah, and actually, it is helpful. I mean, I had a video on a stuck open fuel injector, and that was on a Caravan that I have up on YouTube.
What was it all wet?
It was soaking wet. I mean, yeah, I mean, it was.
Scanner Danner, aka Paul, has pulled number 3 spark plug boot already, and he's going to get a tool to pull it out of there. So we're going to pull this plug out, or are we just going to look at it?
I'm waiting on an extension.
You can do it with our mind?
Yes, that would be sweet.
I bet you I can do it with my
mind.
mind.
If evolution's true, I always said that down the road, like our children's children will have like vice grip fingers, and I'll just be able to grab that plug and turn it by hand.
Well, watch this. Yeah. I'm going to do this right now. I'm going to remove the spark plug with my mind. Poof! Ow! It's still hot. Well, anyway, I told you I could pull the spark plug just through magic. Anyway, here's the spark plug. What we got here? What are we looking at?
Look, again, I don't do spark plug. I mean, this isn't my thing, so you're up now. You know, I mean, it looks like a spark plug to me. It's not wet.
It's not wet.
Yeah.
It's not wet.
That's right.
I would expect something that was linear. I'd want to pull like maybe the one next to it to get a look at it to see what was going on. But it looks a little sooty. It doesn't look, I would expect something that was lean to look a little bit cleaner, if I'm honest.
Right.
Because it doesn't, I'm not really seeing that.
But remember, lean from what you're talking about, lean misfire where we're actually getting some fuel and a burn, I'm saying there is no burn in that cylinder.
And that's kind of where I'm going.
Maybe it's not going to be white. Do you know what I mean?
Maybe, yeah.
Because that's the theory behind the bright white
so that there is
plug.
Combustion that took place.
But it's real hot.
The fact that there's no combustion taking place and the spark plug is just firing, doing absolutely nothing in the cylinder. That's probably what we're looking at.
That's why I don't like the spark plug analysis. I just think there's so many variables.
Well, you're absolutely right. Yeah. But what I'm talking about is looking at the difference between this plug and the guy next to it. Yeah. I think you'll glean more information from doing that than necessarily just pulling the one plug. And I'm not saying you need to pull the next plug.
Yeah, no.
I just wanted to satisfy my own curiosity and see what we got.
Yep.
Kind of nice to see the AC Delco plugs in a GM too.
Yeah, for sure.
I like seeing that.
Yeah, me too.
Now that we've got the plug back in, now what?
Well, there's a couple different ways we can go to identify this condition. And one would be to look at the injector current, and we can actually see mechanical movement in the injector current waveform. The reason I say current instead of voltage is if you look at the engine, you can't get to the injectors very easily. So what we can do easily is put an amp probe at the fuse box that feeds all the injectors, and we can actually pick up each injector firing from the fuse box.
So we can actually look at the injector waveforms. Now let me just throw one little monkey wrench into this whole thing. What about a vacuum leak on that particular cylinder?
Sure, absolutely. I think with a vacuum leak, though, what we would have, and I didn't do this, and I probably should have, is when you hold the engine at a higher RPM, if it's a vacuum leak on that cylinder, generally that misfire tends to go away. It'll actually get a lot smoother. Now, so when you guys were in there and you held it at 2 grand, did it still feel real rough to you?
I could hear it at the tailpipe.
It sounded like it to me too, so I don't think so.
And why would that be?
Well, vacuum isn't as important at higher RPMs.
Well, you lose it as the throttle opens.
And pressure's
the closer you get to wide open throttle with intake vacuum, it drops off to absolutely zero. So
it's funny you say that.
Throttle.
Seriously, I shot a video on this yesterday, and I have the footage. I'm just editing it now to put up there on showing an intake runner vacuum leak causing a single cylinder misfire.
So that would be basically the difference. So this is the reason why we continue to pursue this whole fuel injector theory.
Yes.
Because so far the evidence points to that.
That's right. And the other thing too that I didn't even think about, if it was a intake runner leak, we would have had high hydrocarbon readings.
That's the other thing that I was going to, maybe we would have seen something different on the gas.
Absolutely, because you're still getting the fuel in that cylinder.
You're still getting the fuel, you're just getting too much air.
Too much air, and it's putting the flame out, and our hydrocarbon levels would have been real high.
Exactly.
Lean misfires, is high hydrocarbon levels.
So there is some method to this madness.
Absolutely.
All right, so let's take a look at the injector.
All right, cool. All right, well, we can do injector from the fuse box, which would be current. We could do injector control wire.
But didn't you mention also that the fuse box also controlled the ignition as well as the injector? So the fuse for the ignition signal is also for the injectors.
And so it's going to make the picture a little bit noisy.
It'll be really muddy.
Yeah, I mean, we could try.
We'll be looking at two things at once, so we won't really be able to isolate.
But they don't fire at the same time, so I think we could still pull it out of there. So you'll see
It'd be more
coil,
difficult
fire,
to
injector,
isolate.
coil, injector. I think that's the pattern.
Okay.
We still might be able to zoom on just
Why
the
make it
injector.
difficult though?
That's not difficult.
Okay.
Pull the infuse
Well, you've got the
put
eyes for it.
Yeah, well, you know,
You
it
got
might
those
be.
$6 million
Sometimes it's
eyes.
muddy. I would agree. But we could go control wire at the computer, which is going to isolate the injector itself, and I would choose the computer because getting to the injector on this car is really not going to happen.
Okay.
It's
so
there.
you're going for the output of number 3 fuel injector
Correct.
directly out of the pin connection at the computer.
That's right.
Because the computer controls all the grounds.
That's right.
For the fuel injectors themselves,
That's
which
correct.
energize the solenoids, which cause the thing to open and add fuel to
You
the
got
cylinder.
it. And we can actually see mechanical movement in that waveform if you know what you're looking for.
I've never seen this. Why don't
Yeah.
you show me?
All right, it's way cool. One
Let's
other
do it.
thing we could do
Okay.
is we could put a secondary ignition probe on the number 3 cylinder, and we can look at the firing event, and you can actually see a lean misfire and what one looks like.
So the KV won't be as great?
On the spark line, the KV jumps real high on a snap on a lean misfire.
Okay.
I actually have this in my book, plug.
He wrote a book.
Yeah. In my misfire section on no spark diagnosis, I'm showing a stuck closed fuel injector and a little case study on showing that ignition firing event and how high that is. So we have like 3 different tests that I would choose to use right now. Amp probe at the fuse box, scope at the computer, or secondary ignition KV. Either way, if we do the secondary ignition and we see that high KV that I'm looking for, we're still going to do one of the injector tests.
Now let me ask you, if we don't have a fancy lab scope,
Yes.
is this possible to do with like maybe a DVOM?
No.
Not quick enough.
No, it's not quick enough.
That's the
and-
difference between a lab scope and a DVOM. DVOM's good for just general readings,
right.
but lab scopes measure down to the millisecond.
Right.
You need to watch those
That's
events
right.
down to those milliseconds.
Yeah, when we're talking about looking at a fuel injector pattern where the whole event's 2 milliseconds long at idle, and I'm narrowing in on a fraction of that to see if this thing's moving or not a chance you're going to pick it up with a multimeter.
Okay, so we know that we can rule that out.
Yeah.
So we gonna
Which
quit
one you wanna
talking
do?
about your book.
Yeah,
and-
which one you want to do?
I like the pin connection at the computer.
Pin at the
Because
computer?
I mean that's really easy.
That-
I can see it
honestly,
right
that's
there.
probably the best of the 3 right now because of where we're at. So, and what we can do at the computer too is we can look at a known good and a known bad, and then we can.
So we can maybe look at cylinder number 4
That's
and
correct.
cylinder number 3?
That's right.
Can we put both of those on the screen simultaneously?
we can.
So we can look at a good cylinder
We can
versus
do
a
that.
bad cylinder?
Yes, we can put
This
all
guy's
4 up
awesome.
if we want to.
Well, all right.
We'll do 2.
All right, first
Two's
we got to
good.
figure out what wires go to what.
That's right.
How do we
so
do
we
that?
got to pull the wiring diagram, and we can do that over on the table if you want. And we can mark out what pin it is, which is important, and then we got to pull that computer up where we can work with it and see if we can find it.
All right, we're wasting time.
All right, cool.
Okay, so like this would be the computer itself,
That's half of it. Are we still going?
and
Okay.
and this over on the other side of the diagram would be another.
Yes, and one of
And
the
are these both the same connectors?
They are.
Okay.
Actually, no. There's 4 different connectors. If you look close, it has on here C1, and there's
Okay.
80 pins.
And connectors always start with C, don't
That's
they?
correct. And then this one says C2, and
Okay.
there are 80 pins. So there's 2 different connectors for this computer.
Okay.
One of the things with these Mitchell diagrams is the dotted line always shows you a partial view of that component. So you see the dotted line around the computer, that's not a full view of it.
Right.
The full view, again, was both halves put together.
Okay.
As a comparison, if you look at the automatic transmission, you see a solid line on this one. That is the complete view of the automatic transmission.
So there's only one connector coming out of it.
Well,
is
there
what that
might
would
be
indicate.
more,
Well, then-
but there would be all the wires that are down there.
Okay, so all the wires coming out of that
That's
are here
correct.
because everything is solid around
That's
the
correct.
outside,
Yep.
as opposed to what you have over here at the
Dotted
computer.
line.
It's a dotted line, and you can obviously see that over here you've got 2 dotted lines,
That's
so
correct.
representing 2 different connectors going into the same component.
You got it.
Okay.
So I'm going after the number 3 injector, and one of the things I look at, like on initial, is when you see common wire. So I see gray, 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 and gray. Those are going to be your power feeds for the injector. So I'm not going to follow the power feed circuit. I'm going to follow the control wire, which is a pink and black wire. And I put these diagrams together before. I actually had one of my students help me. Thank you, Josh.
Thank you, Josh.
And we map it out where it goes, and it says right there, injector 3 driver, which is a transistor, and that's what controls that fuel injector. That is on pin 76 on the C2 connector. Now this can be a little bit tricky to identify on the computer. One of the things that I do is I always look at what is next to that wire. So it's pink and black. Next to the pink and black is a light blue and black, and next to that on the other side is a space. So I use that sequence to let me know that that is the correct wire, as opposed to if you'd come over here and go on pin 76 on this side, which is actually injector number 2, to know you're on the right wire. So I go by numbers, which are sometimes hard to see, and sequencing on the diagram to help me identify.
Well, that's really misleading also, because you've got 2 different connectors, so they've split the injector outputs on 2 different connectors, which seems a little strange to me.
But if you look at them on the computer, they're going to be right next to each other.
Okay, right up, okay.
Yep.
Well, let's go over the computer, see what we got.